All right, so in section 5.4, we have some more identities to deal with, like we did in sections 5.1 and 5.2. In section 5.3, we were just solving equations, and so we were using our identities sometimes, and these are going to be some more to help us out. So these are called sum and difference identities. So if this would be used if you had something like, let's say you wanted to do the sine of like x plus pi. So you can't just do like the distributive property. It doesn't work that way. You have to break them up in this way. So like if you have the sine of two things added, and then you see it has plus minus, so added or subtracted, then this is what you would do. You take the sine of the first thing times the cosine of the second. If it was a plus to begin with, you would put a plus back. If it was a minus, you'd put a minus. So the signs kind of match up there. And then you do the cosine of the first thing and the sine of the second thing. With the cosine of a sum or a difference, you do the cosine of the first thing times the cosine of the second thing. And then the symbols in the middle switch around. If you had addition earlier, you would do subtraction. If you had subtraction, you'd do addition here. And then you'd take the sine of the first and the sine of the second thing. Tangent looks totally different, but you know, this is how it goes. So it's a big fraction. You have tangent of the first thing. And if you had addition before, you'd have addition again. If you had subtraction, you'd have subtraction. And the tangent of the second thing. On the bottom, you would do 1. And if you had addition earlier, you would do subtraction this time. And then if you had subtraction, you'd do addition. And then you'd multiply the two items. So they're kind of weird to, you know, explain on the video, but, you know, you're going to see them used in a minute, and so it won't be too bad. It's just formulas to use. All right, so example 1. So find the exact value of sine of 165. So 165 is a problem because that's not on the unit circle. That's not one of the normal things that we usually deal with. But if I can figure out two numbers that I know that add to 165 or subtract to 165, then I can use my rules up here. So I came up with 120 plus 45. These are two angles that I know everything about, and they add up to 165. So we are going to do the sine of 120 plus 45 right here. So that means I can split it up using this rule right here. So it's a sine of 120 degrees times a cosine of 45. And it was addition, so I'm going to keep addition here. Then I do cosine of 120 times the sine of 45. And so these are things that I know. You know, I got my unit circle. All right, so I need the sine of 120 degrees. So 120 degrees, my sine is right there, radical 3 over 2. And, whoopsie, wrong button. So I need radical 3 over 2. Cosine of 45 is radical 2 over 2. Cosine of 120 is negative 1/2, and the sine of 45 is radical 2 over 2. So I end up getting the square root of 6 over 4 minus the square root of 2 over 4. So I basically have the square root of 6 minus the square root of 2 over 4. And that would be the exact value for sine of 165. All right, so over here I have cosine of pi over 12. Now pi over 12 might be thinking like, oh no, like what is that? So remember pi is 180. So if you want to get the degree form of this to kind of like mentally think about it in an easier way, you could do 180 divided by 12, and that gets you 15 degrees. Or you could go through the steps of doing pi over 12 times 180 over pi. But either way, that would get you 15 degrees to change degrees. So 15 degrees is something I know of. So I'm going to use, let's see, 15. How about 45 minus 30? So 45 minus 30. So I'm going to put it in radian form just because it was given to me that way. So cosine 45 is pi over 4 minus 30 is pi over 6. All right, so I'm doing the cosine of pi over 4 times the cosine of pi over 6. And with the sine rule, the cosine rule, if it's a subtraction, I'm going to put addition in between. Then I do the sine of pi over 4 times the sine of pi over 6. All right, so and then we just do those. Cosine of pi over 4 is square root 2 over 2. That's cosine of pi over 6. Pi over 6 is right here. Cosine is square root 3 over 2. Plus sine of pi over 4 is square root 2 over 2, and then this is 1/2. So if we put it together much in the same way we did over there, I get square root of, I get square root of 4, so that's just 2. I'm going to make this all over 4. So up top here I have, I'm sorry, that's square root of 3. So that's the square root of 6 plus radical 2 up there. Okay, and that would be it. That would be the exact value. All right, so now we're going to start using these in a different way. Oops. All right, so in example 3, I want to find, actually the same thing, I just want to do a tangent one. So tangent of 135. Now I know that you know 135 is the tangent, is, you know, it's a 45-degree angle, so it's going to be -1 in that quadrant. But just to like show you how the tangent one works. So 135, why don't we go ahead and use like 180 minus 45. So 180 minus 45 is 135. So I'm going to be doing the tangent of 180 minus 45, just to show how the tangent one works, even though we wouldn't really do it for this because we know the answer. So for the tangent rule, I need to do the tangent of the first and plus or minus the tangent of the second part. So in this problem, it was subtraction, so I'll be doing the tangent of 180 minus the tangent of 45. All right, on the bottom, I'll be doing 1 plus the tangent of 180 times the tangent of 45. All right, so tangent of 180. So if I go to 180, here it is. The tangent is the sine over the cosine, so the tangent is 0. All right, so I'm doing 0 minus the tangent of 45 is 1 over. Then on the bottom, I'll have 1 plus 0 times 1. So I end up getting -1 over 1, which is -1, which we knew was going to happen anyway. All right, so example 4. I want to simplify these expressions by basically like using the rule to break this parentheses apart. So the cosine rule says I will do the cosine of the first one times the cosine of the second part. The minus in the middle changes to a plus, then I will do the sine of the first part times the sine of the second part. Well, these are things that I know. You know, pi is the point -1, 0, so the cosine is -1 times cosine. The sine of pi is 0 times sine. So when I do this, this goes away, it's just 0, so I just get negative cosine. So it turns out that this expression just turns into that. Right. On letter B. In letter B, these are angles that I do not know. I do not know the sine of 200 and the cosine of 40 off the top of my head. But I can look at this pattern and I can see that sine cosine plus cosine sine, this was just an expansion of this problem right here. So this is really just the sine of the two things added or subtracted. And because there is an addition in the middle, this was really just asking for the sine of 200 plus 40. So we're just using the formula backwards. So that means it's the sine of 240, which means, oh, that's something I know. So if I go to 240 degrees on my unit circle, there it is right there, and there is my sine, -√3/2. So you can go use it forwards or backwards. All right, so example number 5 right here. So example 5, we're going to use this rule to expand this expression. So notice I have the sine of these two things right here. So I'm just going to expand it and write it out. It's going to look a little bit weird to begin with, but just stay with me for a minute. So the sine of two things subtracted. All right, so the sine of a difference. And so that means I'm going to do the sine of sine -1 radical 3/2. Then I'm going to multiply that by the cosine of the second part, tan -1 of x. Right? The symbol in the middle, minus, stays minus. Then I'm going to do the cosine of sine -1 radical 3/2 times the sine of tan -1 of x. All right, so this one's a little bit special. But the only thing on here that I know right away is this first part. Sine, inverse sine, these wipe each other out, and out pops radical 3/2. Right? For the other part, though, I have to draw, for this back part right here, I have to draw a triangle whose tangent is x. So I'm just going to draw a random triangle. I don't know where the triangle is. I'm going to use this angle here. So that's my angle that I'm doing the tangent of. The tangent is the opposite over the adjacent. So I'm going to say x over 1. So the tangent of this angle right here is x. Then I have to find the third side using the Pythagorean theorem. So my third side is right here. So that would mean that that side, let's say c squared, equals x squared plus 1 squared, which is 1. So c would equal the square root of x squared plus 1. So this is the square root of x squared plus 1. Right. And so now I can do the sine, cosine, or tangent of this angle and whatever I need to do. All right, so this is the angle that I need. So what this is saying to me, this part right here, is saying find the cosine of the angle and the angle whose picture or whose angle the tangent of it was x. So I want the cosine of the same angle whose tangent was x. Well, that's picture right here. So if I want the cosine of this same angle, I would say, oh, it's the adjacent over the hypotenuse. So I would say that that is 1 over square root of x squared plus 1 minus, all right, so this next part, I have the cosine of the sine when the sine is square root 3 over 2. So let's look. Inverse sine of square root 3 over 2. Remember, inverse sine is allowed to produce answers right here. So when is the sine square root 3 over 2? Well, it must be in the first quadrant because it's positive, and there it is right there. This is when the sine is square root 3 over 2. So the answer is the angle of pi over 3. So basically what we're saying here is that, oops, I went back too far. This angle right here is pi over 3. So now this question says, what's the cosine of pi over 3? Well, the cosine of pi over 3 is 1/2. So I'm going to put a 1/2 times. Now this is asking me for the sine of the angle whose tangent was x. So I'm going to go back to my picture over here. What is the sine of this angle right here? Well, the sine is the opposite over the hypotenuse. So I will put x over the square root of x squared plus 1. All right, now we'll just clean this up a little bit and be done. All right, so I got square root of 3. Let's look at my denominator is already matched, so I'm going to put 2 radical x squared plus 1 down there. The first part is square root of 3 minus the second part is x, and there is my answer. I won't make you rationalize that. All right, moving right along. So now we're going to use these in some identities. So obviously on number 6, the left side is the thing to go with. I'm going to try to expand that to see what happens and prove that it's equal to cosine of x. All right, so a sine, it has a subtraction. So I'm going to do doing the sine of pi over 2, which I know, times a cosine of x. I don't know why I wrote 9 right there. I'm going to keep minus, then I'm going to be doing the cosine of pi over 2 times the sine of x. So pi over 2 is, up here, it's at 0, 1. So the sine of pi over 2 is 1. Cosine of pi over 2 is 0, so that's nice. Okay, so that's gone. So there we go. Cosine x equals cosine x. And I was correct. All right, so number 7, same thing. I'm going to work on the left side right here because it's looking like I have something to do. All right, so cosine of x plus y is cosine of x times cosine of y minus sine of x sine of y plus this next part expanded would be cosine x cosine y plus sine x sine y. All right, so it's a lot of writing, but it's really easy when you're done. These two things cancel out. They're exactly the same. And then I have 2 of the other parts they match. So I'm going to say I have 2 cosine x's cosine y's equals, and I'm finished. Alrighty, looks like maybe we'll finish early. So I got those last 2 problems here. All right, number 8, verify this identity. So it's tangent with subtraction. I'm using a big old fraction. So I will do tangent of the first part, and you keep the same symbol, tangent of the second part. All right, and then on the bottom, you do 1, and you change the symbol, plus, and you do tangent of x, tangent of 180. All right, so 180, let's see, 180 is negative 1, 0. So the tangent would be the sine over the cosine, so the tangent would be 0. So I get tangent of x minus 0 over 1 plus 0 times tangent of x. So you can see that this is gone, that's gone. So it's just tangent of x. And that's it. All right. So number 9, finally we have one in an equation. So we're going to have to expand both of these things right here. I think you'll probably understand or notice that there'll be some cancellation here because I have a plus and a minus, the same thing. So there's going to be some easy canceling, and then we'll just solve it. So I get the sine of x times the cosine of pi over 4, which I know, plus cosine of x sine of pi over 4. Now for the second part, this guy right here, that would be sine of x cosine of pi over 4 minus cosine of x sine of pi over 4. They'll equal to -1. All right, so I do have a matchup right here that cancels. And then for the other one, I have two of them. So I have two of these sine x's, cosine pi over 4's, equal -1. Well, I know the cosine of pi over 4. Why don't I just put that in there right now? So I have 2 sine of x, cosine of pi over 4 is square root 2 over 2. So the 2's cancel. So I have sine of x plus radical 2 equals -1. So I end up getting that the sine of x equals -1 over radical 2. So if we rationalize that, I get the sine of x equals negative radical 2 over 2. All right, so where does that happen? When is a sine equal to negative radical 2 over 2? And A, S, T, C. So it happens here. Oh, nope, not there. Hang on. Oh my God. Oh, that's not the one I wanted, sorry. All right. Never mind. All right, so A, S, T, C, it happens down here and right here. So that's a 45-degree angle, so I'll be saying x equals, let's see, 5 pi over 4. And this is sine, and the question didn't say to stop at 2 pi, so I'm going to just say plus 2 pi n to be safe. And the other place is 7 pi over 4 plus 2 pi n. All right. So all you have to do is watch this video and take notes, and make sure that your classwork is finished, those 20 problems on solving from section 5.3. Do not do these problems right here. We will do them in class, or you will do them in class next time, and I'll see you later. Bye-bye.